Hi everyone, welcome back to this series of AOAD lectures on design at the detailed system level. Today we will cover how to define operations. So let's get started. Here's a quick review of the bank accounts class that we ended up with at the end of the previous lecture. It looks something like this. So we've defined all our attributes. In order to create a class design diagram, we should also assign operations to it. Today, we will teach you how to do that. Here is the UML syntax for operations. Yeah, you've seen this kind of thing before. Okay, so it's not as scary as it looks. And once again, I will go through each part bit by bit. The first thing you should notice is that once again, there are plenty of square brackets. And we know that everything in square brackets is optional. So the only things that are not really in square brackets is this. So the mandatory parts of an operation in UML is only the name followed by parentheses. Now in particular, the parameter list is optional, and we'll talk more about the parameter list later in this video. Therefore, if I just want to define an operation in my bank account that allows me to close the bank account, I could simply call it this, close followed by an open and a close bracket. Next, let's take a look at the return type. And the return type is the type of the value that's returned by the operation. And this is preceded by a colon. Now therefore, if the close method returns a Boolean value, which tells us whether or not this bank account was successfully closed, then I would write it like this. If an operation has no return value, it should return void. Now, other authors in other textbooks may say that if we do not have a return value, then we assume that void is returned. However, in AOOAD, we will only assume that an operation returns void if you explicitly state that the return value is void. Like this. Next, let's talk about multiplicity. And the multiplicity allows the operation to return a collection of values. So for example, we might have a getStudents operation, and the getStudents operation returns a list of students. In this case, this list of students could have between 0 and 30 students. Next, let's talk about visibility. And visibility has the same meaning as for attributes. So once again, it could be public, private, protected, or package visibility, and this applies to the operation itself. We will talk more about visibility in the next lecture. So for example, if getStudents is a protected operation, then we will put a hash sign in front of getStudents. Just like for attributes, you can also define properties for operations, and it is defined in a similar manner. So if I wanted to say that the getStudents operation returns a list of students, and this list of students is ordered by student ID, and not only that, all the students are unique within this list, then I might define it in this manner. Finally, let's talk about the parameter list. Parameter list has its own definition, and a parameter list is either a single parameter or multiple parameters divided by commas. So a parameter list is simply a list of parameters. So what is a parameter? Once again, everything in square brackets is optional. So the mandatory part of each parameter is only the parameter name, a colon, followed by a type expression. And this type expression simply says what is the type of the parameter. So for example, in the getStudents operation, we might define a parameter list like this, which says that the getStudents operation takes a single parameter called mg, and it is of type module group. It might have multiple parameters. For example, it might have a second parameter called sort of type integer that tells the getStudents operation in what order to sort all the students from this module group. Next, let's talk about the direction. And a direction can take values of in, out, or return. If a parameter is denoted to be an in value, that means that it serves as an input to the algorithm. And if it's denoted as out, then it is an output value. In-out represents that this parameter is both an input as well as an output value. And finally, if it's denoted as return, then it's actually a return value. And in fact, it takes the place of the return type of the operation. Next, multiplicity allows operations to take collections as parameters. So suppose I want the getStudents operation to return a list of students. Now, I can write it like this, or I could change it to be written like this. So what happens is that the return list of students is actually one of the parameters, and the getStudents operation is now allowed to return another value, in this case a Boolean. You can also define default values for a parameter, and this is preceded by the equal sign. So for example, I have a set balance operation in my bank account, and the default parameter for the set balance operation is 0. By the way, the third letter of the password is the letter R. R for really annoying. Finally, let's talk about the property string. And this is similar to the property string that was defined for attributes and operations as a whole. So I can actually define a property string for each parameter. For example, in the set balance operation, the parameter of this operation cannot be negative because we are not allowed to have a negative balance. So there you have it. We have at the bottom the definition for an operation, and on top how you define a parameter list, which is simply a list of parameters. This is all you need in order to define the operations for all of your classes. So, taking into account everything that we've learned about operations, here is a new bank account class. On top are the attributes that we have defined in the previous lesson, and at the bottom we might have a number of operations. We have a credit operation that takes as a parameter an amount of type money, returns a Boolean. A debit operation that also takes an amount of money, returns a Boolean. We have a getBalance operation that returns a money. SetBalance that takes in as its parameter some non-negative money value, but it defaults to 0. We have getAccountName, returns a string. SetAccountName, which sets the account name to the input string, and a close operation. All of these operations are with public visibility. Once again, let's take a look at this strange thing at the bottom, which is an open operation that is underlined. And an underlined operation denotes, once again, a class scope or a static operation. Now, this means that we do not have to instantiate a bank account object in order to call the open operation. We can simply call it using the class name itself. There are some operations that are really common, such that almost every class has them. We call these primary operations. There are 4 types of primary operations. There's the constructor, which is an operation to create an instance of the class, and this usually has the same name as the class. There's the destructor, which is an operation to delete an instance of a class from memory. Now, some languages, such as C# or C++, have explicit destructors. So for example, the destructor for the bank account class in C# or C++ would be denoted by a tilde followed by the name bank account. We have getters, which are also called accessors. those are operations that simply returns the value of an attribute. So for example, get account name. And then you have setters, also called mutators. These are operations that sets the value of an attribute. So for example, set account name. Setters and mutators usually returns void. Now because these operations are so common, generally we will leave primary operations out of class diagrams unless there is some reason to put them in. Otherwise, they'll just unnecessarily clutter up the class diagram with not very useful information. So that's it. We're done with operations in UML. In our next lesson, we will discuss visibility. So sorry for the long lecture. Getting a little hungry. I feel like having some mashed potatoes.